short form activities. So if you have any doubt in activities or practice or anything other than that, then you can ask. So yeah, we can start our session. So yeah, anything from activity 1?
Ma'am, question number 5.
Activity 1, question number 5. This one? This one?
Yes, ma'am.
Okay. So what is your doubt here?
Ma'am, I couldn't understand the question.
Okay. So we have to check option by option. So there, the first option, let us first check the first option. So what is the first option? There is a continuous function f from 1,5 to 1,7 such that f of 3 equals to pi. So what is the approximate value of pi?
Ma'am, 3.14.
Right. So pi is approximately 3.14. That means pi belongs to this interval, right? Now, if I take the constant function f of x equals to pi, then it is a function defined from 1,5 to 1,7, right? We can take the constant function f of x equals to pi. Then at 3 also we will have the value pi, right? That means we can define a continuous function, and we know that constant function and continuous function, right?
So,
Yes,
ma'am,
ma'am.
what you're saying is, if I induce 1 in f of x in
Yeah.
place of x, if I induce 1, I will get pi. And if I induce, induce 1, I will get the function is from 1 to 5. So y
Yes.
is 5 at point 1, at point x equal to 1, y is equal to 5. Correct? That's the meaning
No,
of 1 comma 5.
at any point, at any point from 1 to 5,
Okay.
the functional value will be pi.
Is pi. Oh, okay.
The constant function pi we are taking. For
Okay, fine.
odd x belongs to 1 comma 5, and the constant function is a continuous function that we already
Right. Okay.
That means we can define such a function. So the option 1 will be correct. Is it fine?
But when you 1 to 5 is okay, ma'am. Then why is telling 1 comma 5 to 1 comma 7? So
okay, this is a domain and this is a codomain of the function.
Oh, 1 to 7 is a codomain.
Yeah. So this is the codomain.
Okay.
And this is a domain. And because we are defining this function, that means the image of the function should be in the codomain, right? That is why we checked whether pi is in the codomain or not. That means pi is
understood.
in 1,7 or not.
Right. Okay, that's why I think the function f from 1 comma 5 to 1.7. So it's the first 1 comma 5 is the domain, 1 comma 7 is codomain. Okay, understood.
Yes. So we can define the constant function from 1,5 to 1,7 as f of x equals to pi. Okay.
Yes, ma'am.
So what about the second option? You just try. You try and let me know whether it is possible to define such a f or not.
Ma'am, it is possible to define.
How?
F1 is equal to 3 and F10 is equal to 5. Both will be within the range of domain and codomain.
Okay. And how can we define a continuous function?
Ma'am, limit should equal left and right. Both limits should equal, and at a given point, its magnitude should also equal to the limit of the function at that point.
Yes. So the function is continuous over the domain. That means function is continuous at every point, right? So can you consider an example for such a function?
Ma'am, what you have asked, please repeat once again.
Can you construct an example such that f of 1 equals to 3, f of 10 equals to 5, and the function is continuous? I'm giving you some time to construct an example. Try if it is possible. The domain you have to take as 1 to 10, and the codomain is 2 to 8. Okay, and f of 1 is this, f of 10 is this. So can you construct a function example?
Ma'am, maybe it may be a parabola or x power 3 functions. Any?
Yeah, like do you have the specific equation of the function?
No, ma'am.
Anyone?
No, ma'am, I couldn't figure out. Because
Okay, so
If it is in the range, the domain is from 1 to 10, is 10 inclusive?
yes, it is the closed interval 1 to 10, right? That means
Okay.
we are including both 1 and 2. If there was an open interval, that means we have to exclude them. But because we have the closed interval, that means we have to include both 1 and 10.
So this should work now, ma'am, because 1 to 10, and then if it is the range is 3 and 5, 3 and 5 is there in the interval at 2 and 8, no? 2 to 8.
Yes.
So this should also be correct.
Yeah, this is correct. But I'm asking if you have a particular, any example in your mind. If not, there is no problem.
Example is like y is equal to 2x in the second case, but then that doesn't satisfy the first one.
Yes. So can we break the function in such a way so that at the common point they satisfy it?
Break the function, yes.
Can you do that?
F of 0, I mean, we need to take f of 0 plus.
F of 0 we can take because 0 is not in our domain.
Sorry, 0 we can't take.
Yeah. So we have from 1 to 10.
x plus 1 could be one part of the domain, because 1, if you add 1 to x, x is 1, then y is 2. X is 2, y will be 3. X is
Then we have
4.
to take x.
The second one doesn't get satisfied, no?
Yeah, but you can break the graph to up to a point. One, say for example, 1 to 5, I will say x plus 1. And from 6 to 10, I'm just thinking loud. I don't know. I don't have a
So x
specific.
plus 1 is not possible, right? Because
Yes, it is not possible.
x plus 2 you can take.
Oh, x plus 1 is 3. Okay.
X plus 2 is
2.
is
Yeah,
fine.
x plus 2 is fine. So because we have x plus 1 equal to 3 is already given. So x plus 2. So if I give 1, it will be 3. If I give 2, it will be 5. If I give 3, it will be.
So can we take like that f of x equals to x plus 2
X plus 2.
for 1 when x equals to 1 and 2?
Yeah.
That means x is actually
Yes. And then 2x
like
when it is greater than
yes,
Yeah, greater than.
and then that is
this
Yeah.
2x when it is greater than
correct. That is what
5.
So x plus 2 when 1 is less equals to x less equals to 2, and not 2x, it's over 2.
X over 2. Yeah, expect, yes.
No, still we have a problem. Still we have a problem, right? This is also not possible. Okay, so we will try to construct an example later maybe. But we can define such a continuous function, right? Right?
In pieces, I think you explained
yes.
last session. It's
Yes. So the thing is, like we can define such a function so that they are taking this type of value. So it is possible, right?
Yes,
Yeah.
ma'am.
Yeah. So it is better if we can construct an example. So we will try to construct an example later, maybe. Okay. What about the third option? There exists a non-constant continuous function f from R to R which is bounded. Bounded means there should be a upper bound and again
Lower
there
bound.
should be a lower bound. Yes.
Possible, na?
Yeah. So you have to think about it. Is it possible?
Yes.
Construct such a function. How? Example? But non-constant.
Acha.
We have a example. No, okay. We need a continuous function. Okay. So yeah, try to think about it. Is there any example? R to R, but bounded. So that means we have to construct an example for which the domain is R and so whether okay.
Codomain is limit to a certain value.
If this is a codomain, then we can construct such a function. But if this is a range, then we can't do that, right? Range, then it is not possible, right? So
Yeah.
range means every point will have a pre-image, right? That means there will be like if I take any point which is near to the infinity, like such a large number, that number should have also a pre-image. So if R is the range, then we can't define a bounded function. But if R is the codomain, then we can define, right? For example, we can take our sin x, right?
Yeah, sin x is bounded by 1 and minus 1, right?
1 and minus 1. But there R is a codomain, right?
Yeah.
But if R is a range, then we can't define. So they haven't mentioned here whether R is a range or codomain, but we have two different type of possibility, right? Because there is nothing mentioned here. Like R can be range, R can be codomain also. So we can't directly say that there will be a function, non-constant function always, right? So the option should be incorrect. Okay. Because we have two different possibilities, right? If R is range, then we can't define such a function. But if R is a codomain, then there are some example of such a function. But for any, like when we don't have any clue whether this real number, the second R is range or codomain, that means it can be range, it can be codomain, anything, right? In that situation, we can't guarantee that we can always define a non-constant continuous function from this to this, which is bounded, right? So this option will be incorrect. Okay. Okay. Any doubt?
Ma'am, if it is given f varies from R to R, we always consider that it is codomain, domain and codomain are given. So how we will?
Can you repeat again your doubt?
Ma'am, in any question, if it is given function is function value means f is from f from R to R.
Mm-hmm.
It means it is given that domain is real and codomain is real.
Yes, yes.
Then how we can say that it is range or codomain? Second
Uh,
R.
yeah, so the thing is, they should mention it at least here for this question, because it depends on the range or codomain. So if they take R as range, then it is not possible. Like in another question, like if you have to check the continuity or not, in that case you should not be bothered about whether it is range or codomain, but for particularly for this question, it was needed. Okay. So because there are two possibilities, if R is the range, then we can't define such a function which is non-constant and bounded. In that case, the option will be incorrect. What is in the answer?
No, ma'am, when you say non-constant, that means there is a variable.
Yeah.
It could be x or 2x
Yes.
or x
Yes.
square or 5x square,
Yes.
but there is no constant component, pure constant in the
Yes.
equation. Like for
Correct.
example, in the earlier one part, we looked at such as
X
if
equals to
f of
5.
3, f of 1 is equal to 3, f of 10 equal to 5. Those are all constant functions,
No,
right?
no. The thing is, at a particular point, you will get a constant always,
Okay.
right?
Okay.
Right. But constant function means at each point it will give the same value. That means we
Okay.
took the first example, f of x equals to pi for any x.
Correct.
It was an example of a
Constant.
constant function.
Okay. So there exists a non-constant continuous function. So
Yes.
so there is a variable inside the equation.
Yes.
So you cannot get a constant value.
If R is range, that means for any real number we will get a pre-image, right?
Correct.
So
Domain.
in that
Codomain.
case, yeah. If R is range, but if it is codomain, then not necessarily, right? So if R is range, then the function will not be bounded. Correct. R is because R is range. We know that our y coordinate is our range, right? So the whole y coordinate is range means the function will be something like that. So it will be going towards infinity and minus infinity if it is range. That function should cover the whole y-axis. In that case, it will not be bounded, right?
Right, ma'am. But when you the range could be a subset of a codomain, right?
Yes.
Or it could be same. There are two choices in that.
Yes, that is what I am saying. Yes.
Range can be a subset of codomain, or range could be equal to codomain, same as codomain.
Yes.
Only two options are there.
Yes.
And here they are saying that in the question there exists a non-constant continuous function f from R to R, which is
R to R.
bound. So in this case, first R is a domain, second R is you can have two options. Either it could be a range or a codomain.
Or a codomain, yes.
Right? Which is bounded. That is what I understood from this question.
Yes.
Now, if you take a range,
then it is not possible.
Because you are actually limiting, you are having a subset, assuming it's a subset of codomain. So you are basically limiting range will be smaller than codomain.
Yes. So that means if the range is bounded, that means the function is bounded, right?
Correct.
Range is basically representing the function. So if range is bounded, then function is bounded. So if R is the range, in that case, obviously R is not bounded, hence the function will not be bounded. But if R is the codomain, and then we can take the range, for example, -1 to 1, then we can find the function sin x, right? But I guess here they have took the R as range. So if R is range, then we can't define a function. Can you check the answer? What is the answer given? Anyone? Is the third option correct or not? But I guess they have took R as range. So
then third option correct.
Third option is correct.
Hmm.
Okay. That means they are taking all the second set as a codomain. So in that case, the example we have f of x equals to sin x, right? This is a function from R to R and it is bounded, right? Is it fine, whatever I explained? If you have any doubt, you can unmute yourself and ask. So this example will work for this third option. So then the third option is correct. Okay. And what about the fourth option? What about the fourth option?
It is wrong only.
Why?
2 to 3 has to be bounded, I suppose.
Okay, so if the domain is bounded, then even we can define an unbounded function. For example, if I take this function, this is continuous in this domain and this is unbounded.
Okay.
Agree?
Agree.
Any doubt?
No, I didn't get you, ma'am. How can 1 by x minus
This
2?
is a continuous function in this domain.
1, no, it is
And when
unbounded.
Okay, starts with 2. 2 is not there, so next
Yes.
will be 3 because it's open limit.
Yeah.
Therefore,
Like
So
we
2 is
have all the points between 2 to 3,
all the
including
points,
2.
yeah.
including 3.
So it's always will be okay.
When x will be going towards 2, this will be going towards
1.
infinity,
Infinity.
right?
Yeah.
So this is a continuous function from this domain to R, and this is a unbounded function, right?
Yes, but 2 is not included now.
Yeah. 2 is not included, but this function is unbounded, na? Because this is going towards infinity. If the 2 was included, then the 1 over 0 is undefined, right? But whenever you are getting a smaller and smaller number in your denominator, then you will get a larger and larger number in a result, right?
But it's unbounded only on the positive direction. But if you on the other side, you are starting with
a function is bounded means it should be bounded both, like it should be bounded above and it should be bounded below, both.
Okay.
If
But
any one is not happening, that means the function is unbounded. Like if it is
Okay.
not bounded above, that means
Right.
it is unbounded.
Okay, understood.
Okay, so we know that 0 comma 1 over x graph, right? From 0 to it is going like that, right? So this is also unbounded function. So this will also look like same. The point will only. This is the difference. We're shifting the same thing. Okay, so we will get this type of graphs. Suppose this is a 3 and this is a 2. So this will be going towards infinity. That means it is unbounded above. That means the graph is continuous and it is unbounded. Okay. Okay. Any doubt?
No, ma'am.
Okay. So it is clear to all of you, right?
Yeah.
Okay.
So when it is at 3, it should be 1, no? It is passing.
Yes.
But this graph shows it is passing through the origin.
Yeah. That means this point will be 1.
Yeah.
Like 3, 1.
Yes.
Okay. Any doubt in this question? Anything else? No?
No, ma'am.
Good. Okay. Next.
All the cases are correct, huh? In that?
We can check. Yeah, all the cases should be correct then.
Yes, ma'am. All the cases
All
are
the
correct.
options are correct, right? Yeah.
Yes, ma'am.
So we found example for all the options are correct. Okay. Next, this one. Have you solved it?
Yes, ma'am.
What about this?
Mm.
Okay. So I'm scrolling it up. Okay. So yeah. Anyone? Any doubt in 8.1?
Ma'am, in the earlier question, I have a question. The continuous one, you gave an example 1 by x. What was that?
1 by x minus 2.
Yeah. So when it is so here, sorry, here you cannot take 2, but input can go from say 2.1 to 3.
Yes. Not
So
2.1. Like we don't know what is the exact number. This is the like the number
whatever.
immediately after 2.
Immediate after 2. So I'm assuming any it should not take 2, but it can take anything about
Yeah.
2, but it should limit to 3. But
Yeah.
how do we get infinity, ma'am? That's where I'm.
Okay. So
So
when
3.
x will be tending towards 2, then this x minus 2 will be tending towards 0, right? And then 1 over 0 will be tending towards infinity.
Okay, x minus 2. Okay, but x equal to, we cannot take x equal to 2, right, ma'am?
No.
Because x2 is not included in the.
Yes. That is why we are taking the sign tending to. That
Okay.
means it is something near the point 2, not exactly 2.
Okay.
Exactly
So in
1
the
by 0 is not
correct.
defined.
Okay.
Right?
Yeah. So it's unbounded on the at tending towards 2. Okay.
Yes. Okay.
Okay, ma'am. Thank you.
Yeah. Anything else in 8.1? Nothing?
Ma'am, in that question,
This one?
in question number 5,
Okay.
ma'am, the last option.
Hmm.
Ma'am, it is left side, it is open. That's why we have said that the function
Yes.
will be bounded.
Yes. If the left, like both left and right were closed,
Yes,
in
ma'am.
that case, we have a result. If I have a continuous function maps a closed and bounded set to a closed and bounded set.
Okay, ma'am.
Okay. If for a continuous function, if the domain is closed and bounded, in that case, the range will be also closed and bounded. Here it is bounded, the domain is bounded but not closed, right?
Yes, ma'am.
That is why we can find the example. But if it were a closed, then the function always should be bounded. Okay.
Yes, ma'am.
So if it were close 2 to close 3, then we cannot define the function 1 over x minus 2, right? Because then at the point 2, the function will not be defined, right? At the point 2, the function will be then 1 over 0, which is an undefined number, right? So if we had a close 2 to close 3, in that case, we cannot define that example. That means we will not have any example because we have a standard result for that. Okay. Any other doubt? Anything else? No? If all of you are okay, then I will move to 8.2. Otherwise, I will wait. If you have anything, just ask me. Okay. Okay. Anything in 8.2? What about this one? You solved it? Am I audible?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So, what is the update? No doubt in 8.2 or you haven't solved it? What is the case? If not, then I will pick some difficult problem, then solve them. If you have already solved them, then I will skip it.
No, I haven't solved it. So
Okay. And what about others?
Ma'am, I haven't solved it.
Okay.
Ma'am, question number 10.
Question number 10. This one?
Yes, ma'am.
Okay. So we have a function given. We have the definition of the function given. Also, we have the function is continuous and differentiable at x equals to 1. Then we have to find the value of this given quantity. Okay. So these two are given, right? Continuous and differentiable. So yeah, these two are hidden. So if the function is continuous, then we know the definition. And if it is differentiable, then also we know the definition. Just try to use this. If it is continuous, then left hand derivative and right hand derivative are equal. And this is equals to f of 1, right? Because it is continuous at x equals to 1. So we have limit extending to 1 plus f of x equals to limit extending to 1 minus f of x equals to f of 1, right? Now what can I find from this equation? What is limit extending to 1 plus f of x? What is the value of this?
Ma'am, L plus K plus M.
Correct. So this is L plus K plus M. And what is the left hand limit?
K plus L.
And what is f equals f of 1?
K plus N.
Correct. That means we have this, right? Now K plus L will be cancelled out. So we will get M equals to 0. So first value we have M equals to 0, right? So we have used our first hint and we got the value of M as 0. Now we will use the second hint and we will find if this is differentiable, then what should be the value of other two, right? So what is the left hand derivative? Left hand derivative is limit h tending to minus f of 1 plus h minus f of 1 by h, right? And this should be equals to right hand derivative, right? Because this is differentiable at x equals to 1. Is it fine? Is it fine?
Yes, ma'am.
Yes. Then we will put the value. H tending to 0 minus means 1 plus h will be tending to 1 minus. That means we will take this one, right? So this will be k h plus 1 square plus L minus k plus L, right? By h, right?
Yes, ma'am.
And then limit h tending to 0 plus, we will take this definition. So L h plus 1 square plus k h plus 1 plus m minus L plus k plus m by h, right? Any doubt up to now? Any doubt?
No, ma'am.
Okay. Then this L and this L will be cancelled out. And this h we can write it as h squared plus 2h plus 1, right? So we will have limit a is tending to 0 minus k h square plus 2hk plus k minus this k, right? So this 2 will be cancelled out by h equals to limit a is tending to 0 plus, from here we will get hl square plus 2hl plus l and minus l. So this 2l will be cancelled out. Then kh plus k, again minus k will be cancelled out, and plus m and minus m will be cancelled out, right? So this will have, this we will get, right? Then after this, if I take h common from here, then cancel them out. So we will get limit a is tending to 0 minus kh plus 2k, right? Equals to limit is tending to 0 plus, here again we will take h common from the numerator, then we will cancel it with the denominator, right? Then we will get l square plus 2l, oh sorry, so hl plus 2l plus k, right? Now if I put 0, then we will get 2k equals 2l plus k, and then 2l plus, sorry, minus k will be equals to 0, right? So 2l minus k equals to 0 and m is also equals to 0. That means it will give the answer as 0, right? Okay, so this is the thing. Now, is it clear or any doubt? Is it clear? If not, I will repeat.
Yes, ma'am.
Shall I repeat?
No, ma'am.
Okay, so it's clear for all of you, right? What about others?
Yes, ma'am, it's clear.
Oh. Okay. Next, so we can check the answers also. What is the answer? The answer is 0. So we also found the answer as 0. Okay. Yeah. Anything else here? Anything else from this? 8.2? No? What about this 8th question? What about this 8th question? So how is the graph of sin x? Like that, right?
Yeah, it's oscillating.
Right? And if I take the mod, then how will it look?
Only the top portion, the negative portion will be come
Reflect.
to the top. So it will
Yeah.
be
That means
like
it will be reflect with respect to the x-axis, right?
yeah,
So we will get
continuous bounces or continuous semicircle.
like that, right?
Yeah.
So this is mod of sin x. This is 0. This is pi. This is 2 pi, and so on. And this is minus pi, right? Now, can we check the options? What about the first option?
It's true. Periodic with period pi.
Yeah, so it's true, right? We can see 0 to pi it is a semicircle, then again pi to 2 pi is the same semicircle, again 2 pi to 3 pi is the same semicircle. So it will repeat, right? It is the same figure is repeating after a pi length. That means it is a periodic function with period pi. Okay. Everywhere continuous and differentiable. What about the second option?
It is continuous but not differentiable because it has a sharp edge at every
Correct.
intersection with the x-axis.
At every point, right?
Every point on the x-axis.
Yeah. That means it is not true. Everywhere continuous and not differentiable at n pi, where n belongs to z. Agree? Agree with this option?
Yes, ma'am.
Yeah, it's the same as the first one, but in a different.
Yeah.
No, everywhere continuous and not different.
But,
yeah, it's not
this is
different.
the correct,
It's a
right?
other way of telling the step, option
Yeah.
2.
So only the intersection points with x-axis are n pi for n belongs to integer, right? So these are the points where the function will not be differentiable because we have a sharp corner and neither continuous. So it is a continuous function, then this option will be incorrect, right?
Correct.
Any doubt? No? Okay. What about this one? Sixth question. What do you think the first option? First option? Whether it is true or not. Okay, the hint is multiplication of two continuous function is continuous, right?
Yeah.
Ma'am, it will be wrong.
Yeah, because x and mod x both are continuous functions, right?
Yes.
So this is wrong. And the second option will be automatically correct, right? What about the third? Is it differentiable at 0 or not? We can check by the definition, right? We have to check the left hand derivative and right hand derivative. I'm waiting for some time. You just check the left hand and right hand derivative and let me know whether it is differentiable at 0 or not.
It's differentiable.
Yeah, it's differentiable, right? So left hand derivative is limit L tending to h minus f of, we are checking at 0. So 0 plus h means 0 minus f of 0 by h. This will be limit h tending to 0 minus h square by h, right? This will be minus x square if x is less than 0 and x square if x is greater or equals to 0, right? This is the function we have. So as a result, we will get 0. We will get 0. Similarly, if we check the right hand limit, then it will be h squared by h, and in a result we will get 0. That means both the left hand limit and the right hand limit, left hand derivative and right hand derivative exist, and this is basically 0. That means the third option is incorrect, right? And the fourth option is correct. It is both continuous and differentiable on R.
Ma'am, this h tends to left hand limit 0 minus is nothing but f of x minus f of x minus h, right?
Yes. So 0 minus means we are tending from the negative side of 0.
Correct.
Right?
But
that
in the
means when x is less than 0. Okay.
So the formula what you normally use is f of x minus f of h minus x by h.
Okay, so the formula to check the differentiability at a, we denote it by f dash a, and the formula is limit a is tending to 0.
Yeah. F of x H plus A.
Okay.
Mm,
Where we are checking when we are checking the derivative at A, at the point A.
correct.
Then this is the definition, right? Here
Correct.
we were doing this at the point 0. So if I follow the same definition, then we will find it, right?
Oh, okay. Not different. Our point is 0.
Hmm.
Mm,
That means A is equals to 0 here, right?
correct. So this is limit h tends to 0. F of h plus a minus f of a by h is the right hand limit, right, ma'am? But if
0 plus, that means if you are approaching from the right hand side
right
of
hand
it,
side is that formula.
then it
But
is
if
the
you
right. Yeah.
but if you approach from the left hand side, then
Then it
limit
is the
h
left.
tends to 0. Then we use f of a minus f of h minus a by h. Is that correct?
Okay. So you can take this because in that case you need not take this here.
Huh.
You have two options, whether you can interchange the sign here
Correct.
or you can interchange the sign.
Directly use the derivative formula.
Yeah.
So if I
Yes.
use a direct in derivative formula, then it will become limit h tends on the left hand side, LHD derivative.
Yes.
It will become limit h tends to 0, f of a minus f of h minus a by h.
Yes. And this formula is same as this formula.
Okay.
Okay.
So that will give a 0 as an outcome.
Yeah. So let me just, because you just asked about it, so let me like briefly describe. So when we are checking the left hand derivative, we can write it as limit h tending to 0 minus f of
Correct.
h plus a minus f of a by h.
Yeah.
Also, we can express it as
f of a, h
0
tend to 0, f of a minus f of h minus a by h. That is your LHD. The left side is the left hand limit, right side is the left hand derivative.
this. Okay. So these two things are basically same, right?
Yeah.
So
we can use either of the formula, right, ma'am?
Yeah.
Left side is the left hand limit, right side formula is the left hand derivative.
Both are same. Both are
Same. Yeah.
Both are left hand derivative. Okay. So the thing is whether you can change the sign here, otherwise here. This is up to you. The thing is, this definition is easy to remember for me because we have to take this as same always, and we have to just like when we did the same thing in our limit, right?
Correct.
So we are doing the same thing here. So it is easy to remember. That is why we are doing that. Okay. So when h is tending to 0, that means if I have the curve, okay, with h is tending to 0 from the negative side of 0, that means h plus a will be tending to a from the negative side of it, right?
Correct.
Okay. So if suppose this is our a, then this is our f of a, right? And h plus a is tending towards a from this side. That means h plus a will be somewhere here, right? And f of h plus a will be somewhere here, right? Correct?
Yes, ma'am.
And it is approaching from the left hand side, right? And again, here we are automatically, we assume h is tending to 0 from the positive side. So, I guess it is plus a, right? Right? So again, if h is tending to 0 from the positive side, if this is our a, then a plus h will be tending to a from the positive side of it, right? Now, if this is our curve, this is our a and this is our a plus h, right?
Correct.
So this is tending from the right hand side. Okay. And here we were taking f of h plus a minus f of a. That means a number, this number minus this number, which is a negative quantity, right? And similarly here, this is a positive quantity, right?
Yeah.
And this is also a positive quantity, right?
Correct.
So the all over, the whole quantity is also positive, right? And
Yeah.
here, this is a negative quantity and h is tending to 0 from the negative side, means this is also a negative quantity. That means the whole thing is positive again. Right? That means the whole thing is always positive. Whether you can take both as positive or you can take both as negative.
Okay.
Right? That is why we have these two type of possibilities. Okay. Any doubt?
No.
Okay. Okay. Then the sixth question is fine, right?
Yeah.
Okay. Let us then move to 8.3. Anything else in 8.3? Or if, like, just after seeing, if you find something to be difficult, then also you can ask. What about this? The second one? What will be the, what do you think intuitively? What will be the value of the second one? Sin x by root over x. What should be the value of this?
Zero.
Right. So we will multiply and divide with root over x, right? Then we will find limit extending to 0 plus sin x by x, which is 1, into limit extending to 0 plus root over x, which is 0. That means we will find, if you use the multiplication root of limit, then we will find 1 into 0, that means 0 in a result, right? Any doubt? No? This question we just solved, right? So I guess you can do it by your own. What about the fourth one?
Ma'am, in the third question, the dash meaning the
Derivative.
The left hand limit, right hand limit we have to use to confirm it.
Yes.
Okay.
Otherwise, we also know the derivative formulas, right? X power n, the derivative of x power n is what? N into x power n minus 1, right? You can also use the direct formulas. Okay.
Yes, ma'am. Thank you.
Yeah. What about the fourth one? What about the fourth one? If we have f equals to root over 9 minus x square, then we have to find the value of this one. How can you do it? You know L'Hopital rule, right? L'Hopital rule or H hospital rule. You already knew it, right? Is there anyone who doesn't? Is there anyone who don't know this L hospital rule or L'Hopital rule?
No, I'm aware. It should be in a quotient form, and the derivative, both numerator and denominator has to be differentiated.
Yeah. So that means if I find, suppose want to find this limit, and if at that point both the functions are given, like even if you have indeterminate form, that means 0 by 0 or infinity by infinity.
By infinity, yeah.
In that case, basically this limit is equals to limit extending to a f dash by g dash. This is our L hospital rule, right?
Yeah.
So we have this function. What is f of 1 then? f of x is given root over 9 minus x square. Then what is f of 1?
Ma'am, root 8.
Root 8.
Yeah. So we have root over 9 minus x square minus root 8 by x minus 1. So if I put 1 instead of the functions, like instead of x, then we will get 0 by 0 form, right? Is it clear?
Yes, ma'am.
Yeah. That means we can apply the L'Hopital rule. Then what should I write in the next line? What is the derivative of this function? What is the derivative of root x?
Ma'am,
1 by 2.
2,
1 by
1 by
2.
2 root 9 minus x square into minus 2x.
Correct. And this will give 0. This will give 1. That means by 1. That means this is what we have, right? Is it
Yes,
fine?
ma'am.
Okay. Now, can we put directly 0? Can we put 0 instead of x? Oh, sorry, we need to find it at 1. Sorry.
N equal to 1, ma'am.
Yeah, sorry. Then we have 8 into minus 2 will be cancel out. Minus 1 over 9 minus 1, right? That means minus 1. Is this the answer? Can you check? Any doubt? Any doubt? No? Okay. What about the fifth one? Fifth one, again, we have to use the L'Hopital rule. I'm waiting. You just try to calculate and let me know the answer. I'm waiting for you. Same, try to express it as either 0 by 0 form or infinity by infinity form. Then try to conclude. Can you express it at 0 by 0 form?
X by e to the power of x will be the
Infinity by
formula.
infinity.
Then you induce infinity into x, it will become infinity.
Yeah, that means
Infinity
we
by
will
infinity.
get infinity by infinity. Then we
Infinity.
will apply L'Hopital rule. So what we will get?
So it will be 1 by e to the power of x.
Then we will put the value. Then we will get 1 over infinity. That means 0, right?
1 over, yeah, 1 over
0
infinity.
is the answer.
0 is the answer, right?
1 over infinity is 0.
Yeah. Okay. So you can do it, right? Okay.
Ma'am, 1 second, ma'am. In the earlier question, you may, when you induced 9 minus x square, when you the derivative 1 by 2 into, can you just do the derivative of f of x, ma'am, once again? I missed
So
out that
f
part.
dash x will be, first we have to do the derivative of root
1 by
over
2.
x. That means 1 over 2 into root over 9 minus x square, right? Then again we have to do the derivative of this part. So this will be minus 2x.
Minus 2x. Okay.
Okay?
Right.
Yeah?
Yeah.
Okay.
But normally, sorry.
Yes.
Normally, the way you do is you do this 9 minus x square to the power of 1 by 2. So you bring that 1.2 to the left, and then that will become 1 by 2 into 9 minus x square. That's the first
Or
step.
to the power minus 1 by 2. Right? You're telling about the derivative, no?
Yeah, derivative only.
Yeah, so we have basically 9 minus x square to the power half.
Correct.
If we do the derivative, then we will get half will be multiplied. So it will
Correct.
be half into
Half into 9 minus x
square
square. Yeah.
to the power half minus 1. That means minus half, right?
Okay.
So this minus half will be basically 1 over root over this number. Then basically we are applying the chain rule here.
Correct.
Yeah.
Okay, ma'am. Thank you.
Okay.
We got confused.
Okay, is it fine?
Ma'am,
Ma'am?
for question number 5, ma'am, question number 5, x into e power minus x, how its value will be 0. We can
Okay.
take 0 into
you
infinity.
can express it as in this form, right? Then it is in infinity by infinity form, right?
Yes.
Now we will apply L'Hospital, so we will find this. Now if you apply the limit,
Yes, ma'am.
then
It
we will
will be
get
0.
1 over infinity, that means 0, right?
0. Yes.
Yeah.
Yes, ma'am.
What about the eighth question? Any idea how to solve it? Any idea? Any one of you just can unmute yourself and let me know if you have any idea.
5 plus, so if I have to make f of 9 equal to 6, then I have to write x plus y in form of 4 plus 5 plus 4.
Okay. We have to find the value of this.
So f differential of 9.
So we can directly use the definition. Na?
Okay. By h.
Right. Then f of 9 into f of h minus f of 9. That means f of 9 we can take as common. So we will get this by h, right?
Why we are directly taking limit h tends to 0, that formula? We are not using the LHT and RHT here.
Because they have given, we have to find the value of f dash of 9. That
Correct.
means we have to directly assume that the derivative.
Oh, its derivative is existing at 9.
Yes.
So the formula for the derivative of at any point of f of a or f of x is equal to limit h tends to 0 f of x plus h minus f of x minus h by h.
Yeah.
So f of x plus h is what here? F of h, x is x plus y. X plus y. No, here if in this formula, if you substitute f of x plus h in place of x, we need to introduce x plus y, right?
Yes. So we are taking x equals to 9 and h equals to y. So we will get f of 9 into f of h minus f of 9. Then we can take f of 9 as common. So in bracket, we will get f of h minus
24. Huh?
No,
Answer is 24. Huh?
Okay, you got 24. Let us check what is the answer.
No, I didn't get that explanation, ma'am. Can you
Okay,
repeat
if you
again?
use this relation, we
Correct.
can express this as f of 9 into f of h, right? Then f of 9 we can take as common. So then we will get f of h minus 1, right? If you multiply this, what we will get? The same one, na?
No, how can you split that f of x plus h?
F of 9 plus h. Using
Okay.
this thing. F of x plus y equals to f of x into f of y, right?
Correct, ma'am.
That means f of 9 plus h will be f of 9 into f of h.
Okay. So you're introducing 9 in place of x. Okay, because
Yeah.
you have already have a derivative f of 9.
Yeah. X and y are any real number, na? And
Right.
h are 9 also real number. So we can take any real number and apply the formula. Okay.
So now, 9 plus h minus f of h.
Okay.
Okay. So yeah.
Now, f of 9 is 6, we know. So this will be 6 into limit h tending to 0, f of h minus 1 over h, right? And
Yes.
this is basically f dash of 0. How? So, because f dash 9 is defined, that means this term should be defined, right? When h is 0, that means if this is defined, this portion should also be 0, right? Otherwise, we will not get 0 by 0 form and we can't then define the integral. We can't define the limit in that case. That means f of h, f of 0 should be equals to 1. So, f of 0. So here we will have basically f of h plus 0 minus f of 0 by h, which is f dash of 0, right? And f dash of 0 is 4. This is given. That means 6 into 4. 24. Right? Any doubt? Any doubt?
It's complex. I really couldn't get your explanation. Sorry.
No, madam. What I'm trying to do is f of h minus 1 by h is there. So when h tends to 0, the denominator also becomes 0.
Yes.
So as denominator is 0, and since
Numerator should be also 0.
Yeah, since it's differentiable, it cannot be infinity. I mean, by 0.
Yeah.
Even numerator has to be 0. It is forced.
Yes. Otherwise, this will not be defined. Like the limit will not be defined.
Yeah, some real number by 0 is not defined.
Yes. So,
So,
and you know
numerator
that
has
the
to
limit
be
is defined. That means the numerator is forced to be 0.
forced
Right?
to be 0. So that's why you are telling the entire limit is a 0.
Yes. And it is 0 means
0 by 0,
0
indeterminate
means,
form.
that means f of 0 is equals to 1, right?
Yes, madam, correct.
Yes, ma'am.
Because
Yes, ma'am.
something minus 1 is 0.
Yeah.
So f of h is should be 1.
Yes, correct.
Okay.
Okay.
F of h is 1. So f of h is 1. Because of that, the limit, how it came to, it is given f of h is f of
Now
this
we
limit.
know that when we know that f of 0 is 1, that means this term we can also express it as f of h plus 0 minus f of 0 by h, limit h tending to 0, right? And this is nothing but f dash 0, right?
Yes.
Is it clear now?
Okay.
How did you find f of 0 as is equal to 1?
Because the numerator should be equals to 0 when we put the value in the equation. So h is tending to 0. That means when we put the value of h as 0, then we should get the numerator at 0. That means f of 0 minus 1 should be 0. That means f of 0 should be 1. Right? Otherwise,
Okay,
if I get any finite number by 0, then the limit will not be defined, right? But we know that the limit is defined. So the numerator is forced to be 0 here. Is it clear?
yes, ma'am, understood.
Okay, so clear for all of you, or if any one of you have any doubt, you can ask. No?
Okay, ma'am.
Next. These things are easy. So we can go to 8.4. Yeah. Anything from 8.4? Anything? No? So if you haven't solved it yet, I will recommend you to solve it first, and then if you have any doubt, then ask. Otherwise, if I solve them, then you will not get the strategy how to solve it, right? So you have to do it by your own. So if you have any doubt, then ask me. I will clear the doubt. If you don't have any doubt, then maybe you can solve them first, and then in the revision session or in any another session, you can ask your doubt. Do you have anything else? No?
No, because not solved.
Yeah, I
Yeah.
can understand. But if I solve it, then you will not get the strategy, right? So you should use your own brain to solve this. This is the case. So
So,
I
ma'am,
want, yeah.
when is the revision planned, ma'am? Revision
Okay,
session.
so tomorrow we will have a first revision session,
Okay.
and then Friday we will have the revision session for 7 and 8.
Okay.
Okay, so then you just try to solve the rest of the problem before Friday. Then if you are facing problem, then ask me on Friday. And also we have the recorded version of the solution of activity questions and practice assignment. You can also go through the recorded if you are facing problem. Okay.
Ma'am, in the last session, when you are discussing about week 7, you gave in a similar session you solved some problems which helped us to for the assignment, for the graded assignment. Can you give some problems in that space?
Okay, so the solve with the session, the thing is, because the crowd is so less, we
Okay.
have decided not to take the solve with the session.
Okay.
Also, we have the recorded version of solve with the sessions. This is one of the reason. So what you can do, you can go to the playlist.
Okay.
Then go to the maybe activities, problem solving, something is there.
Okay.
And then you can find the solve with us for every week in this folder.
Okay.
In the main YouTube channel, you can go to
Sure.
there. So the solve with us is recorded there. Okay.
Sure.
But maths
For the-
1 assignment solution videos.
Okay.
Okay. If you want, I can also show you maybe.
Yeah, it will. This is for the previous term, right, ma'am?
No, it is not the live one.
Okay.
It is just recorded. It is not the live streaming. It was recorded. Okay. After going to playlist, you can, this assignment solution videos. Okay. And you will get the whole playlist here. So week
Correct.
8, all the AQs and PQs are there. You can see, right?
No, this is for which
And week
session?
8 solve with us here also. Okay.
No, this is for which session, ma'am? This is for the current session, current term, or the previous term?
Yes. No, the activity questions and practice assignment and solve with us are same for all the sessions. Like almost same.
Okay.
Can you just guide me how to go to it?
How to
Get to the solutions?
Okay. Just go to the official channel, then playlist.
Okay. How official channel?
Yeah, ITMBS. YouTube channel.
Okay.
Then this maths 1 assignment solution videos, you can go. And then there are recorded videos. You can go through the videos. Okay. So week 8 AQ PQs are there. week 8 solve with us also there. You can go through them. Okay.
Yeah.
Okay. Thank you.
Yeah. Anything else? Any other doubt? No? Okay. Then it is better if you go through the problems and try to solve them. Then let us discuss it on Friday. Okay.
Wednesday, ma'am. Tomorrow, right? No.
Tomorrow we have revision
Oh,
for
1 and
5
2.
and
Okay,
6.
5 and 6. Okay.
Yeah.
Right.
And Friday we will have for 7 and 8.
Sure. Okay.
So Friday we will discuss about them. Okay. And because you have the graded assignment deadline, that is what I am asking. Before that, if you need them, then you can go through the videos. Okay. Okay. Then if you have any other doubt, you can ask. Otherwise, we can end the session.
Ma'am, tomorrow, what time will be the revision session?
Same
Because
time.
one is on 4 to 6 is a TA session is there.
Yes, sir.
You will be sending a separate invite tomorrow
Yes.
for it. Okay.
Yes.
Because that is not scheduled.
Yeah. This is not scheduled yet.
Okay.
So we will send the announcement.
Okay. Right.
Okay. Yeah. So you can find it in your calendar also.
Sure.
The same Zoom link will be there. Okay.
Okay. Right.
Okay.
Okay, ma'am.
If you have any other doubt, then ask. And otherwise, we can end.
Okay, madam. Thank you for the session. Good night.
Thank you. Thank you, ma'am.
Okay. Welcome. Good night, all of you.
Bye.
Thank you.